Let's solve a couple of numericals to get practice on Fleming's left-hand rule. So here's the first one. A proton moving towards east enters a uniform magnetic field directed downwards. Find the direction of the force acting on it. So first let's get our directions clear. This is north, this is south, this is east, this is west. Up, down. All right, so up is outside the screen, down is into the screen. That's how we'll do it. And to figure out the force, we're going to use Fleming's left-hand rule, which basically says you stretch out these three fingers such that they are perpendicular to each other, all of them mutually perpendicular to each other, as you can see. And then what do these fingers represent? Well, I remember FBI. Thumb represents the force. Forefinger represents FB. B stands for magnetic field. Don't ask me why B, but that's how it is. So magnetic field, FBI, and this stands for current. So we have to align our fingers accordingly, and we'll get the direction of the force. So great idea to first pause the video and see if you can try this yourself first. All right, let's do this. A proton moving towards east. Proton is a positively charged particle. So if it's moving towards the east, then the current is also towards the east. And so FBI, this finger is pointing towards east. Enters a uniform magnetic field directed downwards, FBI. This is the magnetic field. It's directed downwards. So I have to point this finger down, keeping this way. No, not like that. I'll rotate it like this. There it is. Now I'm just going to confirm. Current is to the east. Magnetic field is downwards. Perfect. And so the direction of the force acting is the thumb. And so the force is to the north. All right. Let's do a second one. An electron moving vertically upward is deflected towards the south by a uniform magnetic field. Find the direction of the magnetic field. So in this case, we are given the direction of the current in terms of electron. We're also given in what direction the force is acting. It's deflected towards south, so the force acting on the electron is to the south. We have to find the direction of the magnetic field. So again, great idea to pause the video and see if you can do this yourself. All right, let's do this. Let's bring in our left hand and stretch it. So an electron is moving vertically upwards. Now what's important is electron is a negative charge. So if a negative charge moves up, the current is in the opposite direction. So the current is actually downwards. All right, so that's the tricky part over here. Be careful with the electrons. Electrons are tricky. So the current is downwards. FBI, middle finger, has to point downwards. Okay, and it's given it's deflected towards the south. So the force is given to me. Force, which is given by thumb, is deflect FBI. So force is by thumb, is deflected towards the south. That means force is this way, downwards, southwards. Force is to the south. Yeah, that's how we move our hand now. So let's just confirm current is downwards. Yeah, and the force is to the south. And there it is. This gives us the magnetic field, FBI, B for magnetic field. The magnetic field is to the east. Now to be technically correct, the magnetic field doesn't have to be towards the east, although east is one of the right answers. There are many answers over here. Why? Because we've seen in a previous video that when you're using Fleming's left-hand rule, even if the angle between the magnetic field and the current is not 90 degrees, even if they had some other non-zero angle, the force direction would still be the same. Therefore, in this example, even if the magnetic field was not towards the east, but maybe making some angle with the east in the downward direction, the force on the electron would still be the same. The electron would still have deflected towards the south. So the magnetic field could be directed this way, making some angle between east and the downward direction, or it could be this way, or it could be this way. So strictly speaking, to be technically correct, the magnetic field can take any non-zero angle between the downward direction and the east direction. Any of them is fine. But usually when you have questions like this, we can always write the magnetic field must be towards the east. That is still a correct answer, one of the correct answers. So what did we learn in this video? Whenever we have to solve problems including magnetic forces acting on currents or moving charges, just use your Fleming's left-hand rule and remember FBI, force, magnetic field, and current.